right, hello everyone. Like I did say, I had like an allergy attack like last week and like lost my voice for a little bit. So thank you for bearing in there while this is recovering. Let's talk about TypeScript. I particularly really like TypeScript. It is my favorite way to write JavaScript. I'm going to say some stuff that might sound like TypeScript's pretty terrible, but I have to emphasize, I really do like TypeScript. It's really dark, so I'm going to assume every single person in here is using TypeScript. And even if you aren't using TypeScript, it's okay. No judgment from me. TypeScript in React, though, is kind of an interesting thing because I feel like you could write just pure React without TypeScript and get just as far as you could with TypeScript. Because React itself is not as challenging as other frameworks, as the API surface is pretty limited. TypeScript, though, for the third party in the ecosystem is really where we see all these benefits. So if you're not using TypeScript, but you're using, say, one of the 6 million different projects on GitHub, from state management, UI libraries, CSS and JS, some other router that exists out there that somebody made on one weekend on a bunch of Red Bull. TypeScript makes all that understandable and actually makes it easy for everyone to just kind of be on the same page about what they're working on. However, TypeScript is very slow. We're going to talk about that. We're going to try to understand why it's very slow, but it's okay. TypeScript is very slow, and we're going to see why. So as Ken and Madison tried to say, I am Mike. I work at a company called NX. We're out there if you want to come hang out. You can find me basically everywhere on the internet as M. Hartington, real original, first initial, last name. You pick one screen name when you're like 13 and then it just follows you around forever. So TypeScript is slow, and we're going to try to address that. But slow itself is actually a pretty interesting term because I can mean slow in one ways, and I'm not really going to hit on all the other ways that that TypeScript is slow, but we're going to break it down to two different points, build speed and editor speed. Now, build speed. This is probably the most impactful part of how we can improve TypeScript's performance. And this comes down to the fact that builds are very complicated. Whether or not we are thinking about running it on our own machines or we're running it in CI, a build speed is really just determined by hardware limitations, how big of a project are we building, do we work in a solo indie dev kind of setup where we're building something rather small, or do we work in the enterprise where we actually have like thousands and thousands of lines of code, if not more? So let's take a look at a real quick demo over here. I use NeoVim, by the way. There's somebody who's around that has that t-shirt, and that did put a smile on my face. We have a project over here. It is a rather simple React project. The only thing to worry about is I'm just throwing a whole bunch of garbage at it. It'll keep scrolling. And the components in here, whatever is in these components, because it's all just generated, doesn't matter. What we're really trying to see here is with a lot of files and rather big files, how can we impact the TypeScript compiler? So I said that the build is really just, the build speed is really just a result of a lot of different factors. We're going to actually change our build because right now it's trying to do the TypeScript compilation and then package everything up with Vite. We're just going to get rid of Vite for this. So that way we have a common platform that we can compare against for every single example here. So let's write and quit this. Now we're going to try to build this and see how this goes. So you can imagine right now what the compiler is thinking It's looking at my components directory. It's looking at my app TSX. It's looking at the massive amount of imports in there. It's looking at all those files. It's really thinking, am I going to be able to take all these files and really have to compile this? What is this person doing? What does this developer even think he's building? I don't know what he thinks he's building, but he obviously thinks he's building something really great. It's not really great. But we're going to see TypeScript actually struggle here. And this is a relatively new MacBook Pro, maxed out on memory and everything. So for this to struggle trying to compile all of this, imagine your CI environment now. Definitely not running latest hardware, definitely doesn't have 64 gigabytes of RAM, probably 16 if you're lucky, 8 for most people if you're using something like GitHub Actions. You're gonna see some slow speeds. So we're gonna just let this run in the background, I think, because we do not have all day. So this is going to take a little while to build, and hopefully if we go back to the terminal, it will complete so that way we can see how long it takes to build. But there is one easy trick that we could use to improve the build speeds. Just stop building big things. I'm not joking. Stop building big projects and build smaller modules. I work at a company that specializes in monorepos, and monorepos are perfect for this because we can take all of those different components and break them down into smaller packages that could then be built in standalone. So let's see. Our build did finish. We took about 112 seconds. Not terrible. Let's take a look at this package over here. So this is basically a similar setup to our first one where we have a single app. And then we have 500 different packages that exist inside of our packages directory. And inside of that, we have, again, just nonsense files. Really just a very, very big project. Let's try to run the build for this. NX, run demo, type check, and we cache things so that way you don't have to rebuild stuff multiple times if it doesn't need it. We're just going to bypass the cache for this so that way we are actually going to go ahead and run. And this is the one that I am most nervous about. Because when I ran it outside as like a make sure the demo gods actually are on my side today, it took about 230 seconds. Yeah. Not really fun. So monorepos can help in certain cases. But if we actually just open up another terminal window in here, we're going to see that the setup that we have in this project might not be ideal. So how many people know what path aliases are? I can't see any of your hands anyway. I don't know why I asked that. So we're going to go look at this. So to understand path aliases, we do have to take a step further back and understand how TypeScript itself works. So TypeScript itself takes a bunch of different files, whether these are relative paths, whether these are pulling in from NPM, and it builds out an entire graph of all the files that you have in your project, and it analyzes all the types that are available, whether they are from DTS files or from TypeScript files themselves. In our very first example, we were just using these relative imports over here, so we were just pulling everything local to the package. However, once we moved over to this first step kind of monorepo, we probably were using this Acme lib1. It seems like a relative import. It feels like it's an import coming from node modules, but it is a lie. Because all paths in TypeScript do is actually map back to an actual path import. So TypeScript would lie to us and say, yes, we are importing this from node modules. Wink, wink, we're actually just going to import it relative to your TS config. And the paths for this, like coming from TypeScript docs, there are a series of entries which remap imports to look up locations relative to the base URL or to the TS config itself. It's more or less just lies. This import or this import from at Acme is the very same as just using a relative file. So our speed is not getting any better because we're still treating that entire project as if it's just one big collection of files. And if we go back and maybe this is still going, it's still building, so it's not that much better. So TypeScript's being asked to resolve files and then also type check them. Path aliases don't isolate code into small modules. They actually still just treat it as if it's in the same project. So we need a way to isolate these modules first. This is where Workspaces come in. If you've used Lerna before, this is something Lerna popularized. And then now every package manager from NPM, Yarn, PNPM, Bun, all support using Workspaces. It's basically just a very nice way to say in our package JSON or in a workspace YAML, if you are using, I believe that's for PNPM, where you can just say, hey, I am treating this root package JSON as my source directory for this workspace. I have a couple different directories that I want to treat as workspaces. So everything inside of apps and everything inside of packages, each of those folders is its own separate project. When we run our npm install or yarn install or bun install, whatever, whenever we actually go ahead and fetch all of our dependencies, our package manager is then going to create links to each of those inside of our node modules. And hey, look, 235 seconds, it finally did build. So in this new example, we have all of these packages actually linked to their root, but they're still listed inside of node modules. So they get resolved differently. And it treats it the same way as if you were just importing something from like React DOM, React Router, what have you. So let's take a look at how this impacts our build. Remember, just moving everything into a workspace, so all of our packages are listed there. And we're going to run time again. And now, because it's treating everything as its own individual package, we actually get a very different output. First, we know that that demo app depends on all these subpackages. So let's build them separately first. This is just something that NX does, but it can be done without using NX as well. So it's going to build all these subpackages before it even gets to the final app. So everything's going to be ready before we need to compile the main thing. And our result is 76 seconds, which is far better than 235. Great job. But that's only part of the solution, because now we've removed the files from being relative and treating them as if they're packages inside of node modules. None of those packages are actually exporting types, so we lose the type information that we kind of want with TypeScript. So Workspace solves resolution. Project references solve types. Project references. Are people familiar? Just give a verbal like yes, shout. Yeah. You don't count, Jeff. Okay, so not many people shouted yeah, and that you're not. It's okay. TypeScript shipped project references in TypeScript 3.0, and it wasn't until August of last year that I actually heard of them. And what they actually are a way to say, let's bring in the type information from other packages and share them. So path aliases point to public index files. So these are basically our public API. We're sharing all the types that we export from that, and that's how we're getting that type information. Project references basically says, hey, let's just point to a directory that has a tsconfig. That project already has all the type information that we could need. It already has all the information for every single type, and then we can connect the graph between what this project is, where its dependencies are, and how those types are being shared. Technical definition from tsconfig, from TypeScript's docs. Path property of each reference can point to a directory containing a tsconfig or the config file itself, which may have any name. So it could just be a tsconfig.json. It could be project.a.config.json, whatever. So it actually improves the type experience by making sure all those types are available. And in fact, if we look at this project, this is a very different project now. Let's go ahead and open up this deeply nested package. I want to go ahead and try to get all the references to this nested package 121.221. Very clever naming. My editor can't find any reference, and it's not because I use NeoVim. This would happen in VS Code. This would happen in Cursor. It wouldn't happen, surprisingly, in any JetBrains IDE, but how they set up TypeScript to work in JetBrains IDE is just, it's magic. I don't know how they do it, and I'm very scared and impressed at the same time. But if we come over to this same exact project, just in a different branch where we're using TS references, we can go in and we can try to get all the references for this. And come on. There we go. We can actually see that this function is actually being used in a few places inside of this model repo. I said this was more correct types, but my boss, Victor, said, no, it's not more correct, it's just correct, which is technically correct, so it is the best kind of correct. Okay. So build speeds. Project references help improve the types. Smaller modules using Workspaces make things a lot faster, and we can actually measure that. What about editor speed? Because this is a really kind of niche problem. Most people are never going to deal with editor slowness. They're never going to have to deal with their editor not being able to keep up. But let's just say, for example, we created a monorepo that used some TRCP routes, and we just created a script that generates over 100 different routes. And inside of those routes, we just go ahead and do some recursive type stuff, like TypeScript tomfoolery. It's just nonsense. None of this is actually helpful, but if you imagine a larger enterprise app with very dense type information, if you're using tagged literal types or template literal types, whatever it is from TypeScript, the more complex a type system is, the slower it takes for TypeScript to actually provide that information. So we see that this is router 99, very, very dense type information. What's the worst that could happen? So let's come in here. We are just going to try to get some completion off of this TRPC symbol. Oh, yeah. That is painful. And now imagine trying to do that for that symbol. And you can see where the pain and frustration, and then you really question your entire career. And for the people who are saying, well, it's because you're using NeoVim. Boom. VS Code, you technically are slow in this case. So this is a very unique type of problem. Most people do not run into this problem. And it's because TypeScript is trying to live evaluate all of those files and generate all the types, which is expensive. If you are doing deeply nested types and doing all this tomfoolery, please don't. Your coworkers probably do not like you. And I can't blame them because this is just not a good developer experience. However, the live evaluation aspect of this is something that we can address. What if we could just tell TypeScript to do less and pre-build all these packages? So again, different repo. The only difference is we are not actually depending on TypeScript to evaluate all the symbols on the fly. We have pre-built each package in here and have exported all those types as DTS files. So if we open up that trpc file again and we were trying to do trpc dot, it's going to take a little bit, it's still slow, but it's going to be a little bit more manageable now that we have pre-built things and we are able to actually analyze stuff statically. So that could be a solution that you might want to consider. Generally though, try not to do any complex types. All this to be said, and then TypeScript team decides to announce TS Go or TypeScript Go, which could change everything. It really could just, throw this whole talk out and I would never have to speak about this again, and then I would be thrilled because TypeScript is fast by default. However, stable release of TypeScript right now is 5.83. The Go port is targeted for TypeScript 7.0, and TypeScript 5.0 was released in March of 2023. So we got a while. TypeScript Go could solve all these things, but I am very pessimistic when I assume that it's going to hit in a couple years or maybe 7.0. Who knows, maybe they will hit it and it'll be great, but things happen. So while we can't guarantee that that's going to work great, we can do stuff right now to better safeguard on our experience. So TypeScript can be slow, but it's probably a symptom of bigger issues that you're having inside of your code base. Build small, isolated modules. Consider a monorepo with project references. Come talk to us at the NX booth. Avoid complex types because you really don't need that complex of a type for something. And then if all else fails, consider pre-building all your modules using either a post-install script or just having it be a step in your dev server. With that, you can kind of avoid most of the pain points and get to benefits of a faster TypeScript experience. All the resources and links in here, if you want to get an example of that, you can just take the little QR code. And with that, thank you. I'll show the links afterwards.